I'm Jatin, and I have a confession to make. While I may love playing video games, I'm not so good at it. Despite putting hours of video game time, I'm not even close to matching the skill set of my friends. So I thought to myself, how can I improve my situation? And you know what? I actually don't even need to get better at the video game when I can just train a bot to do it for me. And that's exactly what I decided to do. And I decided to build a Pong bot built off of reinforcement learning and deep Q learning. And in this video, I'll basically be explaining how I built this bot from scratch. First off, we can start off by importing all the necessary dependencies. In my case, I'll be using Facebook's PyTorch to be dealing with neural networks and deep learning tasks. And then I will be using OpenAI's gym library to actually get the environment and the agent. Now, if you haven't heard of OpenAI's gym, it's basically a very nice library which provides a list of environments. For our purposes, we will be using the Pong environment, and then the agent is also provided, and it's great for all types of reinforcement learning practices. Now that we have actually imported the environment, we have to actually make some tweaks to it. So for our purposes, I mentioned we will be getting the Pong environment, and in specific, we'll be actually accessing the fourth version of it. And in particular, we will be using a special feature called no frame skipping. And this is because I have actually developed many wrappers, or have actually borrowed wrappers to do many of these tasks for us. And if you're wondering what wrappers are basically these functions which I can pass the environment through, and then it can basically alter certain things to make it more memory efficient and overall just easier to work with. So many of the wrappers that I use were actually accessed through OpenAI's baselines with a library, which is actually a library that contains a whole bunch of useful RL algorithms. So I would highly recommend checking it out, and I'll link to it down below. Now that we've set up the environment, it would only be fitting to set up the agent. And the process of setting up the agent is actually quite uninteresting. However, one interesting aspect of our agent would actually be the experience replay of it. So this is actually a unique feature only used for deep Q learning, and it basically allows the neural network to access various experiences or states even after the agent actually experienced it. So this is actually super useful for neural networks, and you can actually read the article below where I actually outline why it's so useful specifically for neural networks. Now that we have both the environment and the agent set up, we can actually move on to defining some key training parameters as well as a loss function. So as for the key parameters, one of the main of which in reinforcement learning is epsilon. So epsilon determines the amount of exploration versus exploitation an agent would do. And this is extremely important in terms of reinforcement learning, and you can also read down below regarding why that is. Now, it is also important for the epsilon to decrease with time. And this is because as the agent learns more and more useful exploiting techniques, the actual amount of exploration it needs to do has to actually decrease, or else it'll actually be set down on the wrong path of trying to figure out the local minima in a not so optimal situation. Now, if that doesn't make sense, don't worry, you can actually check out the article to learn more about that. And as for the loss function, all the loss function really does in this case is it calculates the difference between the predicted amount of reward versus the actual reward the agent got. And then the agent is essentially trying to minimize or actually make the predicted reward the same as the actual reward. So, as for the neural network architecture, I've gone to go with one that is similar to Google DeepMind's architecture. So for mine, I've decided to go with 3 convolutional layers followed by 3 ReLU activation layers. And then after that, it is fed into 2 fully connected layers. Once all of that setup is done, we can actually get to the main part, which is actually training the agent. And to do this, we actually need to initialize the environment and the agent. Now, once that is done, we can also initialize a optimizer. In this case, for each iteration, and in our case, that would be a game. So for each iteration, it basically tries to minimize the loss function. Now, once you've done that, we can actually move on to running the training loop. Now, that part is pretty self-sufficient, and if you can see, the computer is telling me that I basically need 9.3 about 9 gigabytes of RAM just to actually run or train this model. It's quite a bit, and that's why I decided to do it on Google Colab, which is a free cloud notebook platform. Now, it's important to note for my case, I actually imported a pre-existing model or a model that has already been trained to some degree. And this is because when I actually tried to train my model from scratch, I noticed that for nearly 1,000 games, it was actually in the negative region. So the average score it was gaining was actually less than 0. So it was actually losing games and losing points much more than it was gaining points. And just to save time, I basically decided to load in a model from someone else. Now, you can also do this to save time and resources. However, if you want to actually witness the satisfaction from seeing your bot go from like negative 18 to plus 18, I think that is definitely a rewarding experience, and you can definitely feel free to try that out yourself from the interactive notebook that I've linked down below. Now this marks the end of the training process, and now that the agent has learned more and more, it's finally ready to perform. So as for my agent, I was able to get the peak score of 19 points, which is actually quite surprising, which basically means that against a traditional bot, which is the one you play against your computer on hard mode, it's only losing 1 point per game. So it's winning almost every single game, and whenever it does lose, it only gives away 1 point, right? And that's quite surprising. So I would imagine a human like me would virtually lose every single point. Now that we've understood the basics of reinforcement learning, I think it's important to see the larger picture as well. So reinforcement learning has actually been one of the most interesting advancements that has been around for a while, but with the recent rise in computation power, we have been able to realize it. And this has actually gotten us much closer to achieving artificial general intelligence. And this rise has put us more closer to achieving artificial general intelligence. So this basically means reinforcement learning is actually one of the best techniques to developing AI like the ones we see in sci-fi movies, in particular like the ones like Terminator.